So what I'm going to talk about today is, soft skills. Is it a misnomer? What can cognitive science inform us about that? So I'll answer that question first. I think it is. It is a misnomer. And I'll try to argue for it as we move forward. Hope we move forward. Okay, we do. Okay, so this is going to be the structure of my talk, roughly. I mean, we'll go from the brain. So as Jack introduced, I'm really not going to talk much about education, but this impacts education. Most of my fund for this is from research. It's not from education, but it impacts education. That's why I've been interested in it. I've been interested in anything to do with the brain. So today I'm going to do a little bit digression. We'll go right from the brain to the mind. We'll talk about neuroscience, where most of my research projects reside. And then I'll move up to psychology. I teach a course. We've been teaching that for about a decade. A seminar course, 1 credit, 2 seminars called Preparing Advanced Professionals. There are some students smiling. They've been in that course. And so that goes up near the soft skills at that level. So I'm going to try to connect, research projects that we do at the brain level to something up there, and then we'll extend it to psychology, where it'll be more of hand waving. It's territory that I'm not very familiar with. I should explain that, except by working with kids and working with students and others. So I do want to explain that since we'll be all over this place, right? I'd encourage you to wear your seat belts, your mind belts or brain belts, because we will be all over the place. I have no choice. I'll have to keep jumping between areas. So I'll first talk about reverse engineering the brain. It's a new area, brand new area. It stands at the lower level of the brain. And then I'll talk a little bit about what are soft skills as, just a definition. You may have your own definition. Then I'll talk about going from brain to mind. As an electrical and computer engineer, I look at it as going from hardware to operating system to software. And then something else. We don't know, right? I'll talk to you about specific research projects related to learning. How do we learn? And it has huge bearings on how we think, because a lot of that learning I'll talk to you about is unconscious learning. So I'll urge you to look inside. I'll bring this word up constantly. The ability to look inside yourself. So keep that in mind. So what insights does reverse engineering the brain? I just made up that acronym. I didn't have space to fill my slides. What does that have as far as soft skills? So that's going to be the central question you're going to look at, actually. I'll tell you something about what I know, my guess. Soft skills have to be learned. You're not born with it. You cannot, and I'll motivate you based on some of the findings from research. And then I want to stress to especially the students, and actually everyone, including me actually, that abnormal stress can impede learning. And that has huge consequences, including at K through 12 level. So all of this is great. My dad told me, my grandpa told me, grandma told me, you'd say. As an engineer, you see, I'm interested in mechanistic insights. Can you tell me why? And that's what I'll try to do with these slides. Okay. So put your seatbelts on. Okay, we'll start at the bottom, reverse engineering the brain. So National Academy of Engineering in 2008 recognized this as one of the 14 grand challenges. And I've been working in this area a few years before this, so I was really thrilled to see that. So what do they mean by it? I'll tell you a little bit. But first, what are we looking at though? We have a brain, it's about 100 billion neurons arranged in intricate circuits that control lots of stuff, right? And that can go wrong. It can lead to Parkinson's, it can lead to PTSD, depression, and so on. So what do engineers do? What have we been doing? Well, we are interested in neural implants. Can we do something to improve some conditions like Parkinson's? Personalized medicine is a big one. I'll touch upon quite a few of these. Interestingly, the National Academy, when we did that in engineering, the grand challenge from NIH, the Institute of Medicine, they came up with these grand challenges. How does physical activity of neurons result in mental activity, thought? Now, I'm not sure medical folks can answer that question. They need us. They need physicists. They need engineers. So when I talk about engineers, I'm clubbing all the physical science folks in this. Okay? But they are interested in it. It's a NIH grand challenge. Fascinating, right? How does nature and nurture shape us and make us who we are today? That's a big question that's been addressed for a long time. But again, I think engineers are needed there. And how do we protect brains from aging? I think we heard from Marge about aging and all those, and I would encourage that that's probably will be another thing that'll get in there. How do we protect our brain? What about mental health as we age? What consequences does that have to falling and all? This is probably stuff system scientists deal with modeling control, circuits with nonlinear resistors. Those are some areas. And we are actually, neuroscience is one of the fastest growing areas for AI models. Why? Because psychologists will tell you this happens. Can you link it? So AI is needed to bridge that gap for now. And then probably they're looking to add explainability into this. But the challenge is you need to be able to work with neuroscientists, scientists, and psychologists. And we've been doing that for a bit. I'll tell you a little bit about all that. Now, back again to something else, the birth of a new era long, long back. And when Galileo discovered this telescope, it launched this entire area of astrophysics and astronomy. Why? Because that enabled people to get data, right? Tracking Kepler got tons and tons of data, and Newton just looked at all that, and Newton said he could do what he did because he was standing on the shoulder of giants, right? Shoulders of giants. What that did then, what I would suggest is, what's happening today is even educators are saying, turn that telescope around. Can you look inside now? So the question is, why weren't we looking inside? There were philosophers, there were lots of people looking inside 100 years back. Trouble is we didn't have data. Today we do have a lot of data beginning to come out in massive amounts, but we don't know how to mine it. So what our lab and lots of labs are doing is we're trying to build up from bottom up first principles models, similar to what's happening in physics. It's a physics approach, and then AI models to bridge the gap between them. And this is, again, I'm going to flash this by, and when I say there is data, and there are people working on it. Electrophysiology has been around a long time. Optogenetics, you must have heard. I won't read through all that. In math, there's sparse coding, compressed sensing, Bayesian statistics, and all of these, lots of people, including us, we're looking at some of these, including machine learning and AI. So it is a rich area. Okay. Coming back, what does that have to do with soft skills, right? So what I'm going to argue is abnormal stress affects functions at all levels. Stress actually impedes learning. What is stress? This is a very layman's definition. Stress is when your own perception of reality is at odds with what is out there. It's more complicated than that, but let's go with that for now. So what do we do about it? I'll come back to that a little later. So this is in the course I teach, we have 2 book readings. One is 7 Habits of Highly Effective People. And you'd say, yes, my dad told me that, my mom told me that. Let's go over it briefly. I'll tell you there's much more in this than that. Okay, the first 3 habits, I won't go into that in detail, is to develop independence. You're born into this world, you are dependent. That's how all mammals are. We have no choice. You learn a degree of independence. And once you learn that degree of independence, we do a good job of that, actually. If you did that well, properly, then you can go to interdependence, which we need in our society today. Engineers need that a lot. Particularly, scientists and engineers are told you are introverts, which is okay. I mean, I like my equations, I like to. But then when you have to interact with others, it's a stumbling block for us. It raises stress. First of all, I don't believe in it. Why should I do it? I'm just going to argue that you should do it. Whether you would or not, that's up to you. But I think it's important to do is what I'm going to argue. And engineers are good. If I'm told it's important, I know why. Man, I'll do it. So far, I was not told. So that's my logic here. As you do this, as you learn this, I think an important one here is sharpen the saw. Sharpen the saw just means it has important implications. You need physical well-being and mental well-being. please read the book if you haven't, because this has trained managers. This is not a self-help book. It's much, much more than that. It trains managers, and people pay to go and learn all this. I think I have 3 or 4 students right here who have been in that course, as I see. Okay. So again, I'm going to look at why should I believe this, the basis, right? So this is another book we use called Make It Stick. It's by WashU, 2 psychologists there. It's a bestseller around the world. It talks about simple things we thought we knew. It says rereading is useless. If you reread stuff to learn, it's absolutely useless. Massed practice is useless, right? And there are, what is useful? Retrieval practice. Effortful learning. Learning has to be difficult. If you make it easy for the students, you're not helping them. You're harming them, actually. And why? Because it's connected to plasticity in the brain. It's connected to encoding, consolidation, retrieval. And I think I'd encourage you to look that up because I won't have time to go over it in detail. I'll tell you a little bit about learning. So this is something we've done in our lab. There is standard Pavlovian conditioning where a rodent is exposed to shock and tone. And they learn very quickly after a few trials that the tone is predictive of a shock. The funny thing about it is we've got models. I work with collaborators at Rutgers on this. They provide me with data. I fit models, computer models. And we have data to show that this learning occurs unconsciously. You don't even know you've learned. Then you wonder, well, if that is true, what else have I learned unconsciously since I was born? There's a structure in your brain called the amygdala, which stores all your fear memories right since you were born. So what does that do to you? We don't know. I was interested in this. DARPA came up with a program to boost synaptic plasticity. Just wanted to tell you, lots of folks are interested in this. And it is out there. It's fairly important. I'll leave it at that. There's a link you can look at. You can boost plasticity. And I won't go over this video. So this is a video we have. I don't know how to go over this. Well, I will probably quickly. Is there a way I can start this? So this is, as you go through this is actually our collaborator at Rutgers. They have a rodent that's going to come from the left side of the screen. And there's a robot here that's a predator. And the rodent is scared, so it's instrumented, right? It's got fear and reward. It can get the food pellet. It is trying to get the food pellet while it's debating. And that is encoded in an area called the prefrontal cortex. And can you intervene? The idea is that a collaborator wants to intervene there and prevent that fear so that rodent can go get it. So those are ongoing experiments, and we have models of that. I don't know, Fong is here. Fong, is one of my students. We've got computer models to show this, and we are interested in biomarkers. There are high gamma. This is all signal processing. High gamma, that will be biomarkers that will indicate the conflict between reward and fear. Okay? So coming back to soft skills again. So, we talk about six-pack, right? I talk a lot with my son about this. He's interested more in that. And what about six-pack for the mind? So I was glad there is a actual stuff. So I'll come back to this same slide about stress. Stress does affect everyone. Not all stress is bad. Long-term stress can harm your health. There are ways to manage stress. If you're overwhelmed by stress, get help from a professional. These are all from NIMH, National Institute of Mental Health Science. For our students, again, ability to look inside. Why do you have stress? I think you should have the ability to probe deeper, go in and see why are you feeling the way you are. And you'll need some help with that. The question is, why can I not implement all this if I can get to be the CEO and make $1 million? Why can't I do that? I know I want to do it. Why not? I think that's where the 7 habits, make it stick, these insights would come in. That's the pitch here for today. But actually, how do we do it? Well, so coming back to this question, soft skills, I would actually call them well-being skills. Those skills are very much needed for you to navigate life. If you take it that way, believe me, it's extremely important. It has to be learned. If you don't have time to read the book, just check out 20 things 20-year-olds don't get. For all undergraduates, I think probably it should be required reading. Just in my course, I do have students look at that. I think one of the things it says is you have to have 3 mentors. If you do the 6-pack abs, you're more than willing to pay $40 an hour to a coach, right? To get you 6-pack abs. Why can't you get free mentors? I'm talking to the students here. And actually, those mentors holds at all levels, in my opinion. Why can't you? They're more than willing to help you. That impacts advisement. I talked to Jeff Ullman, briefly talked to Dave Grant also the other day. We're thinking of what can we do here for advisement. I think it's extremely important. I think if I were going to go back, I would take a course on individual psychology. Psychology is coming out with very interesting facts because the AI will fill that in. For instance, lying has been underdiagnosed as a cause for psychopathology. Don't lie, just say the truth, right? I'll tell you computer software reasons why that will hold from my point of view. Check out cardinal sins, just Google. Why, when you get angry, what really happens? It shuts off your cortex. It's known. So when you're angry, don't say things you don't mean to, just keep quiet. Right? When you're confused, just do that, right? Talk to personal mentors. So you say that, right? How come I cannot do this? Well, talk to a personal mentor. They'll tell you, they'll help you. Get some 360-degree feedback. Those are extremely important suggestions at all levels of life. So even if you're not stressed, if you want to go to the next level, these are good things to do. Okay? I think all of this, removing stress, this well-being skills will help you go beyond that too. Well, come back to the brain again. Let's say you don't have the time. I don't have the time to do all this. Well, help is coming. Planet Fitness, you go there, right? Very soon, I think we are working on another project with a psychologist, trying to look to see, for normal people, can you go to one of those sessions? Can you have, it's called transcranial magnetic stimulation. It's real. The one we are looking at is, can impulsivity be measured by EEG signals? And can you control it in a simple reward task? So if you don't have time, I think you'll probably be able to visit Planet Fitness. On this side is all your physical, this side is your mental labs. Okay. With that, I think I'll like to thank my lab members. I work with a lot of people, but on the projects that I listed here, our collaborators are Denny Perret from Puerto Rico and Greg Quirk from Rutgers and Puerto Rico. These are my brilliant grad students who actually make a lot of these things happen. Thank you.